not a Monday. Monday, April 30th. Okay, so if we wanted to solve this quadratic, okay, we have 4x squared minus 21x equals 18. Can we use the zero product property?
No.
Why? Right, the problem right now is that our quadratic is not actually equal to 0. Right, I can't factor this out and say that something times something else equals 0 because it doesn't. Here it equals 18, and that's a problem. Okay. So what do you think we could do? If we wanted our quadratic to equal 0, what could we do? Yeah, we could subtract 18 from both sides. Why would we do that?
To get a 0.
Say it again.
To make it equal to 0.
Yeah, the standard form of our quadratic equation is for something like this, where we would have our polynomial, here just so happens to be a quadratic trinomial, equal to 0. That 0 is really important. Okay, and the reason it's important is twofold. First, that's standard form for our quadratic. Second, if we wanted to solve, if we factored and we're going to utilize the zero product property, which we talked about on Friday, we would need it to be in this format. Who wants to explain in your own words what the zero product property means? Or you could just read what you have in your notes, that's fine. Zero product property. What is it? What does it mean?
For any real numbers, a and b, if b equals 0, then a equals 0, or b equals 0.
Yeah, if I was multiplying two numbers like a times b, and I knew it equaled 0, I know that if I multiply two numbers and it equals 0, either one or both of them would have to be 0. So that's what we're going to do when we have our quadratics in this format. We're going to set our entire quadratic equal to 0 so that when we do factor, we can use the zero product property to solve. Okay, what kind of polynomial is this? It's a trinomial, and what kind of trinomial? It's quadratic. What makes it quadratic? Yeah, the exponent. The largest degree here of a 2 makes it a quadratic. Quadratic, and then there are 3 terms making it a trinomial. How do we factor quadratic trinomials?
Multiply the
Say it again.
multiply the
Yeah, I can multiply 18 and 4, negative 18 and 4. We'll actually do this on the next slide. Okay. So we'll multiply 4 and negative 18. What do we get? Negative 72. What are we going to do with the negative 72? Yeah, we're going to find factors of negative 72 that when I combine them, make negative 21. Take a second and find them. This tends to be where a lot of us get stuck, so I want you to take a moment. And if you need to break out all the factors of 72, do that. If you don't and you already have the factors, then in your notebook, continue on with factoring it. If you're struggling to find the factors, list out any factors you know and go from there. Who found the factors of negative 72? You got, did your hand up? What'd you get?
20.3.
Yeah, the factors of 72 that would combine to give us 21 would be 24 and 3. Which one is negative? Yeah, the 24 would be negative and the 3 would be positive. What do we do with those numbers? Yeah, we're going to break out this trinomial. to a 4-term polynomial. Once it's broken out this way, how are we going to factor it? Yeah, we're going to find the greatest common factor of these first 2 and last 2 terms. At this point, you are unfoiling. Okay, so if you need a little reminder of when we foil through, this one term multiplies here and here to give us that F and that O. And then this term multiplies by the same parentheses to give us the I and the L. So when we have it at this level, we can factor the greatest common factor out to find that original binomial. What's the greatest common factor of 4x squared minus 24x? 4x. And what's left? If this is x minus 6, then the other parentheses also would be x minus 6. And what did I factor out? A positive 3. So what are the 2 binomials? 4x plus 3 and x minus 6. And if you factor that and need to check it, just distribute it out, especially for those of you that are going to do the redo for the exam. Any of the redos for factoring, you can just multiply it through and check yourself. Like check your work and see that you factored it properly. So now we're not done yet. I actually didn't carry this equals 0 the whole way. So now I have this. It's the same thing. I didn't change the value in any way. I just factored it. I took that trinomial and I factored to be these 2 binomials. So really what my expression is, it's 4x plus 3 times x minus 0. And when I multiply those 2, it equals 0. Okay. From here, how do we go on to solve? Okay, so I'm going to set both equal to 0. Why? So imagine I was going to graph this quadratic. If I graphed this quadratic, it would look like that, right? When we graph a function, typically we utilize, we've used an x and a y value to graph. Last week when we graphed, we actually put our y value first, and then we had our quadratic function. But notice in this format what the values are. The expression's the same, and what do you notice about the y and the 0? They're taking up the same spot. Which means if I solve here, I'm actually finding the value for x where what? Where y is 0. And on a graph, where is y 0? On the x-axis. And why is the x-axis necessary when we're dealing with quadratics? Because that's where our solution is. So by setting these 2 equal to 0 and solving, you are finding anywhere on that quadratic where it crosses the x-axis. So here, what would our solutions be? How would I isolate x here? Subtract 3 from both sides. Good. Good. And divide by 4. So I have negative 3/4. And here? Good. So the solutions are negative 3/4 and 6. If I needed to see it on the graph, it would look something like this. That doesn't necessarily represent the vertex or the y-intercept. I just showed where they would cross. Okay. If you're solving like this, you wouldn't need to show a graph. I just like to visually show where those values come up. You would just need to represent x equals negative 3/4 and x equals 6. Now we can do this with a real world situation as well. Okay, that's probably more common. But let's show. I'm sorry, were you doing that? You were still writing? I'll go back. You're going to try one on your own, and then we're going to transition into a real world scenario so you can see the difference in your answer, because your answer is going to change. Not change. It'll be represented in a different way. Okay. So let's try this one. X squared plus 14x equals negative 49. I want you to solve that from start to finish. Okay, so solve that quadratic by factoring from start to finish. Now, at the end, after you solve it, make some type of statement about the solution or solutions to the quadratic. You're going to factor the trinomials. That's not where you need it first. So, January track though. Can we factor this the way it is? No, the thing is, we're going to want to utilize, if we're going to try to factor, which would be, if we identify that we have the ax squared plus bx, if we have these two terms, we're going to try to factor. We can't just solve by finding the square root, right? But we're going to want to. We're going to want to factor if we can. So in an effort to factor, what would I need to do first to kind of get this into a format or a form that would be appropriate for factoring? Yeah, we would like for this to be in standard form. So at least we could try it. Now the next topic will be what we do if we don't bring it over. But for now, if we're going to try and factor, which we are, we want this to be in standard form. From here, what are you looking for to factor this? Now think about the ways that we learned how to factor trinomials. To factor this trinomial, what do I want to find?
Two binomials.
Okay, so I'm going to write out two binomials when I'm actually factoring it out. Okay, do I have to do that? Because that method takes a lot longer. Say it again? Factors of 49 and 14?
7. Oh, 8.
Alright, so this is a perfect square trinomial. But even if we didn't identify that it was a perfect square trinomial, what's the coefficient of x squared? So if my coefficient is 1, how could I factor that? Say it again. That do what? I can find factors of 49 and add to 14. Yeah, I don't have to multiply the a value and the c value and break it out into a 4-term polynomial. You don't have to do that if your coefficient here is a 1. You can just find factors of 49 that add up to 14. It saves time. If you factor the other way, you're okay. You'd still come up with x plus 7 and x plus 7. Okay, but because this coefficient is a 1, we do have a faster method to factor. Because if I multiply two binomials through, the only thing I could multiply to get an x squared would be an x times an x. So if I have x plus 7 times x plus 7, utilizing the zero product property, how would I solve the quadratic? I can set both binomials equal to 0. And what do we get?
X equals -7.
And what do you know about that quadratic when it's graphed?
Same.
Which means what? What do you know about the quadratic? It is a quadratic, so it's still curved. So how many solutions do we have? Yeah, there's only one solution here. These are the same number, which means this is where our graph would touch the x-axis. That would be the vertex as well. But that represents one solution. So when you calculate, you're still coming up with two values, but they're the same number. And so that represents one solution. Now, in a real-world situation, we're going to go through this one relatively quickly so that you have some practice factoring. In this example, if you are going to construct a frame for this rectangular photo, you want the width to be the same all the way around, and you know that you want the area of the new picture and frame to be 315 inches. So we're going to figure out what the outside dimensions of the frame should be. Like, how much are we going to add on here? What do I know based on this? All right, I know the actual dimension of my picture, 17 wide and 11 in height. What else do I know? Yeah, I know the total area is 315 inches. Hey, what do I need to know? What do I need to figure out? All right, I need to figure out how many extra inches that I have. How can I do that? How do we find the area? We're going to multiply the length times the width. Okay, so once I add the frame, how can I represent the new length and the new widths? Careful. 11 plus 2x, because on both sides. And here, 17 plus 2x. And what am I going to do with these two values? I'm going to multiply them, and what should they equal?
315.
They should equal 315. Okay, length times width would equal the area. So here's my calculation. Can I solve using the zero product property?
No.
No, why not? All right, so the product of them is not 0, but have I found the product yet? Have I actually? No, I haven't simplified the left side yet, so we can. How would we simplify the left side of the equation? I can FOIL. Yeah, I can multiply out. What would I get? 4x squared plus 34x plus 22x any double-digit number times 11 is the first digit, the last digit, and the middle is then added together, so it's 187. I saw a mathematician if you want to lecture. Am I done simplifying? Were you asking a question?
Yeah. So what did you just say?
Oh, so if I multiply a double-digit number by 11, so like 17 times 11 is 1 is the first digit, 7 is the last digit, and the middle digit is these two added together.
Oh.
So like 33 times 11 is 363. 35 times 11 is 365. Yeah, I saw a mathematician in New York. He wrote a book, so I went to his talk. And the only thing is, I missed what he said. If like when you added them, it was more than 10. I think it just carries, and you would add them. But yeah, pretty fancy schmancy. Am I simplified here? No. What can I do to simplify that equation? I can add my like terms. Yeah. How many x's do I have?
56.
Okay, I'm just gonna rewrite it because I just moved everything. 1 plus 56, and then that 187 minus this was 187. If I subtract the 315 because I want it to equal 0, what's 187 minus 315?
Negative 120.
What was it? Negative. That was right. Do we agree? Can I factor that? The way it is right now, we have a pretty large quadratic. Is there anything I could do to simplify it before I factor the trinomial? Yeah, there is a common factor there of a 4. I can divide a 4 through everything. Right? If I factored out a 4, what would be left? Did you have to do that? No, if you were at this level here, and you wanted to factor and you multiplied 4 times negative 128, and you found factors of that added up to 56, you'd still get the right answer, but it would just take maybe a little bit more time because those numbers are a bit larger. If you factor it out here, you could factor a little bit quicker because, well, let's back up. We'll actually factor it. Because now, what can I do to factor this trinomial? I still have the 4, but if I'm factoring this, what am I looking to find based on how the trinomial is set up? I'm going to find 2 binomials, and how am I going to factor it? So an x and an x. Good. What numbers are going to work there? Numbers that do what? They multiply to make negative 32, but they add together to make a positive 14. What we got? Yeah, positive 16 and negative 2. Can we use the zero product property to solve now? Yeah, we can. We have our quadratic and it is factored. This is what we have. Why am I able to ignore the factor of 4? Do I need that? What does the zero product property tell us? When I multiply terms, yeah, if I multiply numbers together and I get an equals 0, or they equal 0, that means one or both or however many numbers I multiply would need to be 0. So here I'm actually multiplying 3 terms. I'm multiplying a 4 times an x plus 16 times an x minus 2, and that equals 0. Do I need to set every single term there equal to 0? I don't need to do this. Why not? Why do I not need to waste the time to do that? Instead setting up my zero product property like I would do here. Because what? 4 equals 0? Why do I not need that? Because it's not true. Yeah, 4 can never equal 0. Right, so if I knew, think about this, if I was only looking for the values that equaled 0, I can ignore that because 4 never equals 0. It has to be one or both of the other terms, right, which is why I can set the rest of these equal to 0 and solve. So our answers here in terms of the solution of the quadratic would be negative 16 and positive 2. Is that the answer for the problem? No, because what did the problem actually ask us for?
Count it out of dimension.
The dimensions of the frame. What are the new dimension? What's the new dimension of the frame? What am I adding to all sides? Of the two solutions I came up with, which one's really the answer?
2.
Why?
Because you can't have negative.
Yeah, if I'm talking about a real world problem here and I'm thinking about adding onto a frame, I can't add a negative 16. So the answer here would be a 2. If I'm adding on, my new dimensions would be the 11 plus 2 on this side and 2 on this side, which is 15. And then the 17 plus 2 here and 2 here, which would be 21. There's a difference between just solving a quadratic and solving some type of real problem. Even though there's 2 answers to the quadratic, there's not 2 answers to this problem. So you're going to try one of these as a DOL, not a real world problem, just factoring solve. Okay? And then you're going to choose from your practice. Hold on, let me pause this.